All right, we're going to begin solving quadratic equations by factoring in this lesson, and then in the second half of this lesson, we're going to solve using square roots. This is the start of chapter 1.4a. All right, so we're going to start with what a quadratic equation is. You probably heard about these in Algebra 1, but it is just any polynomial equation where the highest exponent of the variable is 2. All right, so for example, something like ax squared plus bx plus c, this is a quadratic equation in standard form. Right, so if you remember in standard form, when we were talking about polynomials, in decreasing exponent order, I have an ax squared, so my squared first, my x term, and then the constant is at the very end, equals 0, right? So the only difference between this and what we did weeks ago with polynomials is that now this is an equation, right? So this time we have something equals something. And the standard form is when it equals zeros, all right? So examples of quadratic equations, any one of these are quadratic equations. Not all of them are in standard form, but these are just some examples. So I have 5x squared plus 11x plus 2 equals 0. This is a quadratic equation because my highest exponent is 2. All right, and I don't have anything bigger than that, right? Same thing here, highest exponent is 2, highest exponent is 2. Notice only this one is in standard form. All right, this is not in standard form. To get it in standard form, I would move that 12. To get this one in standard form, I would move that 18. All right, so that they equal 0. All right, now when we're solving quadratic equations, we're going to learn over the next few lessons a couple different ways to solve them. We're going to start by solving by factoring. Right, now factoring is, again, like I say, it's never going to go away. When we're solving quadratic equations by factoring, we want to get the quadratic equation in standard form first by setting it's equal to 0. And then you want to factor whatever expression is on the other side of the equal sign. And then we use the zero product property. All this property is saying is that we're allowed to set each of our factors equal to 0 and then solve each of those factors separately. All right, so think about it like this. If I have, right, when you factor something, we typically have parentheses times another parentheses equals 0, right? So this is what we want. I want a parentheses times a parentheses equals 0. We're saying the only way to get 0 from multiplying two things is if one of them is 0. So either this factor has to equal 0 or this factor has to equal 0, right? That's the only way that I can get 0 from multiplying things, right? So that's our zero product property. That's all it means. Basically, we're just taking each factor, setting it equal to 0. All right, so I'll start with some examples. All right, starting with this first one. All right, first you always want to check if it equals 0, right? Whenever we're factoring, we always want to set it equal to 0. This first one is equal to 0. All right, so then I can move on to the next step, which is to factor. All right, so I'm going to look at number 1. It looks like the only thing that I can do to factor this is to take out a GCF. Now between 3x squared and x, I can take out an x, and I'm left with the 3x plus 1 equals 0. And then I can't do anything more to factor this, so I'm going to take each factor and set them equal to 0. So I'm going to take x equals 0 and 3x plus 1 equals 0. All right, and then so x equals 0, that's already one of my answers. My other one is going to be, I need to solve 3x plus 1 equals 0. So I'm going to subtract 1 on both sides, and then I get 3x equals negative 1. Divide by 3, and then I get x equals negative 1/3. All right, so that's all we really do in these problems, right? You're going to get various factoring cases, right? But this is just one of them. So I'll try the same thing with the next one. I have an x squared minus 1 equals 0. You can, again, factor this, right? X squared minus 1 is a difference of perfect squares. So to factor this, we can square root the first, square root the second, and then I get an x plus 1, x minus 1 equals 0. All right, and I didn't even mention that at first, right? We do want to check that it's equal to 0, which it is, and then factor it. All right, so then I can factor x plus 1, x minus 1, and then I can use my zero products property to set each of my factors equal to 0. So I do x plus 1 equals 0, x minus 1 equals 0. So then I can subtract 1 on both sides of this equation, and I get x equals negative 1. And then I can add 1 to both sides of this equation, and I get x equals 1. all right? 2 solutions here, all right? And in every single one of these, you should expect 2 solutions. The only time when you don't get 2 solutions is maybe you get 1 solution and it's just you get the same solution twice, all right? And we might do something like that later on in this lesson. The only other time where you might not get any solution is maybe you get a negative under a square root, which we'll do in the next lesson, right? Maybe you see kind of what happens there, but I wouldn't concern myself with that yet, all right? So let's try this one now. Slightly different only because this first thing, it's not set equal to 0. I want to make sure first that it's set equal to 0, so what I have to do is I can subtract x on both sides. So then I get x squared minus x equals 0. And then again, factor it as normal, right? It looks like from here I can take out a GCF of x. And then once I take out an x, I'm left with an x minus 1 equals 0. And then again, use your zero product property. I'm going to set each of my factors equal to 0. So I get x equals 0 and x minus 1 equals 0. X equals 0 is already solved. X minus 1 equals 0, I can add 1 to both sides, and I get x equals 1. All right, 2 solutions there. And then I'll try the same thing with this one, number 4. Again, you always want to check that it's set equal to 0. It is. All right, and now I can try to factor it. So x squared plus 2x minus 8. I'm looking for factors of negative 8 that add to positive 2. And this is going to get me an x plus 4 and an x minus 2 equals 0. All right, and then again, use your zero products property. I'm just going to set each of these factors equal to 0. So x plus 4 equals 0, x minus 2 equals 0. Subtract 4 on both sides, and I get x equals negative 4. Add 2 on both sides of this one, and I get x equals positive 2. All right, so I get my 2 solutions. All right, and that's pretty much the essence of this lesson. There's really nothing crazier that happens here. The only time when it does get a little bit different is maybe when you have harder things to factor, right? Again, but it's the same steps, right? The first thing I want to check, it's set equal to 0. It is, right? It equals 0. And then I want to multiply first times the last, so 2 times negative 15, to find factors of negative 30 that add to negative 1. So what times what gets me negative 30, and what plus what gets me negative 1, right? You don't have to write this if you can do it otherwise, all right? But I know some of you still do, and then some of you maybe also write the factors, so negative 30, and then you write factors, so 1 and 30, 2 and 15, 3 and 10, and so on, all right? In this case, it's going to be a negative 6 and a positive 5. All right, so factors of negative 30 that add to negative 1 is going to be negative 6, positive 5. So I'm going to do x minus 6 and x plus 5 equals 0. I do want to divide by 2, so divide by 2, divide by 2. All right, anytime you have something in front of the x squared, divide by 2. And so I get x minus 3, and then slide that 2 up front, I get a 2x plus 5 equals 0. And then again, use your zero products property. I'm going to set each of these equal to 0. So I get x minus 3 equals 0. And then I get a 2x plus 5 equals 0. All right, and so for one of my answers, I can add 3. Let me write that over here. It's going to be x equals 3. And then I could do the same thing over here, subtract 5 on both sides, and then I get 2x equals negative 5. Divide by 2, and I get x equals negative 5 over 2. All right. Try the exact same thing with the next one. Only difference here is that this is not set equal to 0, right? I want that 16 on the other side. So to get it on the other side, I'm going to subtract 16. And so I get x squared plus 6x minus 16 equals 0. And then I can find factors of negative 16 that add to 6. That's going to get me a positive 8 and a negative 2 equals 0. And then again, zero product property, x plus 8 equals 0, and x minus 2 equals 0. I can subtract 8 on both sides, and then I get x equals negative 8. And then I can add 2 on both sides, and then I get x equals positive 2. All right. Same exact thing with this one. All right, first thing I want to check is if it's set equal to 0. This one is not. I have a 3 on this side, so I just want to move it. I'm going to move the 3, so subtract 3. And then I get a 2x squared plus 9x plus 4 equals 0. And then again, you're going to do first times the last, so 2 times 4. And then you're looking for factors of 8 that add to 9. It's going to be 8 and 1. So I'm going to do x plus 8, x plus 1. And then again, slide and divide, I'm going to divide by 2. And then I get x plus 4. Slide that 2, it's going to be a 2x plus 1 equals 0. And then I can set each of my factors equal to 0. So x plus 4 equals 0. And then 2x plus 1 equals 0. I'm going to subtract the 4 on both sides, and so I get x equals negative 4. Subtract the 1 on both sides, and then I get 2x equals negative 1. Divide by 2, and then I get x equals negative 1/2. All right. Now this one's a little bit different just because we have a fraction. All right, so you could do the same thing as before, and you could do 1/5 times negative 10, and then find factors of whatever that is that adds to negative 1. It's not crazy difficult, but then you'd have to divide, right, when you do your slide and divide by 1/5. What we can do instead, let me erase that. What we can do instead that we learned in a previous lesson is we can get rid of this fraction in the bottom by multiplying the entire equation by a least common denominator. And it looks like 5 is our only denominator here, so I can multiply this entire thing by 5. So I can distribute 5 everywhere, and then this 5 and this 1/5 are going to cancel, so I'm going to get an x squared minus 5 times x is going to get me a 5x. Minus 10 times 5 is negative 50. And then this looks a lot easier to factor. So I'm going to have factors of negative 50 that add to negative 5. Looks like it's going to be a negative 10 and a positive 5. All right, so I can use my zero product property again. I'm going to do x minus 10 equals 0. And then x plus 5 equals 0. So I can add 10 to both sides. I get x equals 10. And then I can subtract 5 on both sides, and I get x equals negative 5. All right, so that's the only difference with this one was clearing the fraction, right? But otherwise, it's still the same steps. All right, last page, couple more examples of all the same stuff. I mean, there's really nothing new. All right, so I'm going to look at this first one, and I'm going to get everything to one side, set it equal to 0. So I'm going to look at this 3x, move it to the other side, right? Definitely start there. So we're going to do a 6x squared minus 3x equals 0. And then again, factor it however you can. This is going to get me a 3x, and I'm left with a 2x minus 1 equals 0. And then use your zero product property. This is going to get you a 3x equals 0, 2x minus 1 equals 0. And then I have two equations to solve. It looks like here I can just divide by 3. And then 0 divided by 3 is 0. So 0 is one of my solutions. And then my other one, I can add 1 to both sides. And so I get 2x equals 1. Divide both sides by 2, and I get x equals 1/2 as my other solution. All right. The next one looks very similar, right? So we can try the exact same thing. All right, so get everything to one side. I'm going to subtract 2x. And I get 8x squared minus 2x equals 0. And then again, GCF, I can take out a 2x. And then I get a 4x minus 1 equals 0. And so I get a 2x equals 0 and a 4x minus 1 equals 0. Divide by 2 on both sides, and I get x equals 0 for one of my answers. And then I can add 1 to both sides. And then I get 4x equals 1. Divide both sides by 4, and I get x equals 1/4 as my other solution. All right, this next one, again, I want to get everything equal to 0. You could move the x squared right? Maybe that's where your mind goes because you want to try to do less steps, all right? But if you do that, if I do negative x squared, and then I get a negative in front, and then you'd still have to divide by that negative. So I'm not going to do that. Instead, what I would do is I would move everything that's on the right to the left. So I'm going to do plus 6x and plus 9. So then I get an x squared plus 6x plus 9 equals 0. And again, you can factor this. I need factors of 9 that add to 6, and that's going to be a 3 and a 3. So this is a perfect square trinomial. So you also could have done, right, so maybe you wrote it like this, but another thing that you could have done was x plus 3 squared equals 0. But that means the exact same thing. All right, we'd still end up with the same thing. I would get x plus 3 equals 0, and another x plus 3 equals 0. So I can subtract 3 to both sides of both of these, and then I get x equals negative 3, and another x equals negative 3. I get two solutions, but they happen to be the exact same thing. When this happens, you only need to write it once. So I don't really need to see it twice. You can get rid of that. But if you want to write it twice, you can, right? I just need to see it once, right? That's perfectly fine. All right. And then I'll try the same thing over here. So I have a 4x squared plus 12x plus 9. Again, you could do first times the last, 4 times 9, and then you get factors of 36 that add to 12, right? This isn't a really big number, so I can just do 6 and 6. And then I do x plus 6 times x plus 6 equals 0, and then divide by 4. This is also a perfect square trinomial, so you could have also done square root the first, square root the last, and you would have gotten a 2x plus 3 squared right away. All right, but it's entirely up to you, right? Most people would have done it this way, so that's fine, and have done this, right? Done your little slide and divide. So you can simplify this, right? 6 and 4 is going to become a 3 and a 2. 3 and a 2. And then I can slide that 2 up front. So then I get a 2x plus 3 times 2x plus 3 equals 0. And then I would set each of these equal to 0. So 2x plus 3 equals 0. Another 2x plus 3 equals 0. And then we get the exact same thing that we got before with the one solution that shows up twice. So then I end up with a 2x equals negative 3. Another 2x equals negative 3. Divide both sides by 2. And then I get x equals negative 3 over 2. And that shows up twice. If it shows up twice, that's fine. I only need to see it once. All right. But that's all the factoring that we'll do in this particular lesson, right? We'll do more factoring in a little bit, right, when we get to 1.6, all right? But this is really it for this first part of the lesson, right? The second half of this lesson is going to be on extracting square roots, right? And we'll talk more about that later.